Hey everyone, in this video I'm going to show you how to program a linear interpolation program into your TI-83 calculator. If you just want the code, you can see the description below, and then you can code it up yourself. It's only a few lines. And if you want to see where the equation comes from, you can see my other video that I'm going to link to here and in the video description. So let's get started. First thing you want to do is press the program button here, and we want to make a new one. So we'll go to new, press enter for create new, and it's on alpha lock, which means it'll keep typing in letters, the green ones here. So we'll go INTERP, we'll call it INTERP, and then press enter. Now we can start coding in our program. The first thing we want to do is take the inputs that we need. We want the inputs for the two bounding points, the point 1 and point 2, and then the x coordinate of the point that we want to interpolate for. So we want some inputs, so we'll go into program, input output, and then press enter because we want the input. And then I want to show on the screen what the input should be. And the first one that I want to input is x1. So I'll type alpha to get the quotation, and then alpha to get x. So we want x1. And then to get the equal sign to show up, we go into second math, so that'll get us into test. And then equal sign, that's what we want. Press enter. And then close this off with a quotation. That's what will show up on the screen. Type a comma, and then I'm going to call x1. The variable that I'm going to use in my equation when I type it out is going to just be a. I just choose these arbitrarily. Okay, that's the first line. Now we also want to input the other bounding x point, so we do this again. So we go to program, IO, get the input. We can get the x2, so we'll do x2, second math, to get the equal sign, close the quotation marks, comma, and this one I called D. I made this program a while ago. And so we'll do alpha lock to get D, input, okay, program. Now I'm going to put in the x value that we want. So I'm going to do another input here. And the x value that we want, I'm just going to call plain x. So I'm just going to call it x. I'm going to put in a space so everything lines up nicely. I'll do second math again to get the equal sign. And then close that quotation, comma, and this one, for some reason, I called I. You can call these whatever you want, but you'll just have to change them in the final equation. Now we want to put in the y values. So in a similar way, we're going to go through, and I'm going to put in y1. So we're going to do y1, and then we'll put in the equal sign, and then we'll close that off, comma, and I'm going to call this n, again, for some odd reason. And then the last one we want to input, we're almost done. Last one we want to input is y2. So we'll do this, 2, second math, to get the equal sign, alpha equals, okay, comma, and this one I called s. Okay, now to solve the equation. And to solve the equation, we want to go into program again, IO, and go down to number 3. So you can either press a 3 or you can scroll down and then press enter on 3 for Disp, display. And then type this exactly. We're going to type in parenthesis, parenthesis, parenthesis. I made sure the parentheses all worked out. I'm going to say s minus n here, close parentheses, divided by, open parentheses, d minus a, close parenthesis, open parentheses, I minus a, close parentheses, plus n, close parentheses. Now the program's done, so you can press second mode, which will quit. And if you want to run it, you can press program, and here we can go and find it in our program list under the execute, and we'll press enter here, press enter again, and now it's asking for input. So the test that I did in the video was for temperatures and specific heats at constant pressure. So if we just do that one where the first temperature was 250 Kelvin, press enter. The second temperature was 300 Kelvin, so these are the two knowns that I know. And what I want to solve for is the temperature in the middle, any temperature in between these two, to interpolate between the two. And so I chose 275 as my first one. Now the y value in this case was my specific heat at constant pressure, so my first one was 1003 joules per kilogram Kelvin, and my upper one was 1005 joules per kilogram Kelvin, and we solved it. And we got 1004. And this one makes sense because it's halfway. The 275 is halfway between these two, which means the linear interpolated value will be halfway between these two. I can run it again with the second example that I used. So if I go back in here and run it again, and I choose again, my bounding was 250 and 300, and I wanted 280 this time. and my bounding CPs were 1003, 1005, and you can see that we get 1004.2 just like we had in the other video. So now you can use this linear interpolation program for any of your linear interpolation needs. So thanks for watching.